Let's classify this equation of the conics and write it in standard form. So first, I'm going to solve for y from this equation. That is, I keep y on this left side and transform the x squared as well as the 133 to the right side. So when I do that, I get negative x squared plus 22x negative 133. Now I'm going to factor a negative from these two terms. So I can write down this as negative of x squared minus 22x. We also have negative 133. Now we are going to complete the square for this expression x squared minus 22x. So we have to take the half of this 22, which is 11. We should add its square and subtract its square. So let's do that. So therefore this becomes x squared minus 22x plus 11 squared minus 11 squared. We put this bracket minus 133. Now we can write this as y equals, we have negative in front, x squared minus 22x. This one is 22x plus 11 squared is 121. We also have negative 11 squared, which is negative 121. And okay, let's put it here. This is negative 121 minus 133. Now we can combine this three terms as a square of the binomial. That is y equals, we have negative in front, x minus 11 quantity square. And then we have this negative times negative 121 is positive 121. So we put this out of the brackets, which is positive 121 minus 133. And 121 minus 133 is negative 12. So the next step, I write y equals negative of x minus 11 quantity square minus 12. Now this is in the standard form, and this basically represents the equation of a parabola. We can write down its standard form, that is y equals a times of x minus h quantity squared plus k. So when you compare this, this is the standard form of the parabola. When you compare this equation with this standard formula, we can determine that the vertex of this parabola is h comma k. So here it is 11 comma negative 12. And so therefore this conics equation represents a parabola with the vertex at 11 comma negative 12. And since here this one is negative, that is when a is negative, it represents a downward parabola. So it is opening downward. And so this is the standard equation of the parabola. And we have classified this conics equation as a parabola with the vertex at 11 comma minus 12, and it's opening down. We now write the equation of this conics in standard form and also classify the conics. So first, I'm going to subtract 224 from both sides, and I'm also going to combine this negative 30x with the x squared. So I write down this as x squared negative 30x. We then have negative y squared, and this equals negative 224. Now we can complete the square for these two terms, x squared minus 30x. So for that, we should take the half of the coefficient of x, that is 30 by 2, and this gives 15. And so we add its square and subtract its square. So let's do that. X squared minus 30x plus 15 square minus y squared. We can add its squares on both sides. So negative 224 plus 15 square. And so this we can write down as a square of binomial, that is x minus 15 quantity square minus y squared, and this equals this is negative 224 plus 15 square is 225. So 224 minus 225 is positive 1. I'm going to write down this as positive 1. And now we can see that we can divide all the terms by 1 and write down in standard form. So it is x minus pi quantity squared divided by 1 squared minus y squared divided by 1 squared, and this equals 1 divided by 1 is 1. So this is the standard form of a hyperbola. We can compare with its standard form, that is x minus h quantity squared divided by a squared minus y minus k quantity squared divided by b squared. This equals 1. So this type of parabola has the transverse axis on the x-axis. So we see that, I'm sorry, this is a hyperbola, transverse axis on x-axis, and having the center at h comma k. Here h is 15, and this is basically y minus 0 quantity square. In fact, we can write down in that same form. I'm going to write down this y square as y minus 0 quantity square, so that we can determine its center. So we see that the center of this hyperbola, this basically represents a hyperbola. That's the classification of this conics. Center at 15 comma 0, and we can also write down its vertices and co-vertices. Vertices, we have to determine a and b. Here we see that a squared equal to 1, so a squared equals 1 square, so a equal to 1. Also b squared equals 1 squared, so b equal to 1. And this means the vertices are at, since the center is at 15 comma 0, we should add 15 plus 1 to find one of the vertex. So therefore it is 16 comma 0, and another vertices is 15 minus 1, which is 14 comma 0, and then the co-vertices are 0 comma b, because here it is 0, so we put 0 comma 1 and 0 comma negative 1, because if b squared equal to 1, then b equal to plus or minus 1. And so we have classified this as the hyperbola with this information. So this is the standard equation of the hyperbola. Okay, let's do question 7. Here we have this conic equation x squared plus y minus 2x plus 3 equals x squared plus 4x. So since we have x squared on both sides, we can subtract x squared. And subtracting x squared, we see that these two will become cancelled. And I'm going to solve for y from this equation by adding 2x to both sides and also subtracting 3 from both sides. And so when I do that, I get y equals, I add 2x and subtract 3 plus 4x. And so this gives, these two are like terms, 2x plus 4x is 6x minus 3. And this basically represents the equation of a line. That is, this is in the slope and intercept form. When you compare this with the standard form, y equals mx plus b, m represents the slope of the line and b represents the y-intercept of the line. So this one represents the equation of a straight line, or this conic represents the straight line, and this is the standard form of the equation. Uh, its slope is given by the coefficient of x, which is 6, and the y-intercept is negative 3.